In part 3 of this video, I will go over acceleration. Average acceleration is defined as the rate at which velocity changes. So average acceleration is calculated by dividing the change in velocity over the time of travel. Since velocity is a vector, acceleration is also a vector. Direction of acceleration is direction of change in velocity. This is something that we can deduce from this equation as well. There are 3 points to note regarding the acceleration. The first one is, since velocity is a vector and has both magnitude and it has a direction, either can change during an object's movement. So if the direction of the object changes, but the magnitude of the velocity doesn't change, we still have a change in velocity. Therefore, we have an acceleration. So point is, acceleration is change in either speed or direction, or both. Point 2. As mentioned, acceleration is in the direction of the change in velocity, but this is not to be confused with the direction of motion. So, direction of change in velocity is not the same as direction of motion. For example, when an object is slowing down, its acceleration is opposite to the direction of motion. In other words, this object is decelerating. But the third point says we can't confuse deceleration with negative acceleration. So, deceleration is not the same as negative acceleration. Whether acceleration is positive or negative, that depends on our choice of coordinate system. It does not depend on whether or not the object is speeding up or slowing down. To give you an example, let's say I have this coordinate system, and this is positive, and this is the negative direction. And let's say that this car is moving in the negative direction and is slowing down. Since this car is slowing down, the acceleration is in the opposite direction of the motion. So, acceleration is positive. But since the car is slowing down, it is actually decelerating. So you see we have a positive acceleration, but the car is decelerating. For example, let's say the green car now is also moving in the negative direction, but it's actually speeding up. So if the car is speeding up, the direction of acceleration would be in the same direction of the motion. So A would be in the negative direction. But since the car is speeding up, it is actually accelerating, it's not decelerating. So the green car is an example of a situation where we have a negative acceleration, but the car is not decelerating, but it is actually accelerating. Okay, now let's look at an example of calculating average acceleration. Let's say we have a car that is accelerating from rest to 40 meters per second due south in 2 seconds. So from rest, so initial velocity is 0, to 40 meters per second. So final velocity is 40 meters per second. It's going south, and this is happening in 2 seconds. And we want to find the average acceleration. So the first thing we do is we're going to draw the coordinate system. Let's say this is the positive direction and this is the negative direction. And the car is moving south, so it's moving in the negative direction. Since it's moving in the negative direction and v is a vector, so v is going to be a vector that is pointing down or in the negative direction. So vf is negative 40 meters per second. The average acceleration is del v over del t, or final velocity minus initial velocity over time, and that would be negative 40 meters per second minus 0 divided by 2, or negative 20 meters per square second. Just like velocity, we have both average acceleration and instantaneous acceleration. Instantaneous acceleration is the average acceleration over an infinitesimally small interval of time. So this is average acceleration over very small interval time. To test your understanding, answer this question. Let's say we have a car that is moving from rest at point A that is 100 meters away from point B. So we have a car, initial velocity is 0. It reaches a speed of 35 meters per second, and it's going due east. So it's going in this direction, and this is happening in 5 seconds. So the car speeds up to 35 meters per second in 5 seconds. And then it takes the car 20 seconds to reach point B. I want you to find the displacement, distance traveled, average velocity, and average acceleration.